So in this very lesson, we want to find the inverse of a matrix. And to start with, we are going to look at the inverse of a 2 by 2 matrix. Now let's consider the matrix A, which contains the entries. And you can see that matrix A is what a 2 by 2 matrix. To find the inverse of matrix A, which is denoted as inverse of matrix A, is defined as 1 all over the determinant multiplied by what? The adjoint of what? A, where A is the determinant of matrix what? A. So to find the determinant of matrix A, we are going to find the cross product of these two entries. We have AD minus what? BC. And that is the determinant of matrix A. Let's look at the adjoint of A. Now to find the adjoint of A, we are going to transpose the cofactor or co-matrix of matrix A. So we are going to transpose the co-matrix or cofactor of matrix A. So we have matrix A to be, and we have already learned how to find the cofactor of a given matrix. So to do that, we have to first find our minus. Then we multiply the minus by the signs. So we have our minus. Now when we multiply the minus by these signs, we are going to get what? The co-matrix or cofactors. So to find the minus for the first entry, it means we are going to collapse the first column and then the first row. We are left with what? Entry D. So we have our D here. To find the minus for the second entry, we are going to collapse the first row and then the second column. We are left with what? The entry C. To find the minus for this entry, which is this, we are going to collapse this column and then this row. We are left with what? B. To find the minus for this entry, we are going to collapse this row and then this column. We are left with what? A. So this is the minus for this matrix A. To obtain the co-matrix, we are going to multiply these entries in the minus by these signs. So this is going to give us what? Positive D. This is going to give us minus C. This is giving us what? Minus B. And this is giving us what? Positive A. So this is the co-matrix or cofactor for matrix A. And we are saying that to obtain the adjoint of matrix A, we are going to transpose the cofactor of matrix A, and this is the cofactor. So in transposing a matrix, the first row will become the first column, and then the second row will become what? The second column. So we have transpose of matrix A. So the first row will become the first column. So we have D and then what? Minus C. And then the second row will become the second column. So we have minus B and then what? Positive A. So this is the adjoint of matrix A. So we have D minus B and then minus C A. So this is how we find the adjoint of a 2 by 2 matrix. First, we find the cofactor or co-matrix of the matrix. Then we find the transpose of it. It is going to give you what? The adjoint. Now let me give you a shortcut that can be used to find the adjoint of a 2 by 2 matrix. So we have matrix. So we have these 2 by 2 matrix. We want to find the adjoint of A. What we are going to do is what? First, we are going to interchange the positions of the A and D. It means the D will come to the first entry and then A will come to the last entry. So we have D and then what? A. And then we have BC. So we have BC. Then after that, we negate the B and then the C, and that's going to be the adjoint of matrix A, as easy as that. So you interchange the position of A and D, and then you negate the B and the C, and that's going to give you the adjoint of A. Now let's look at examples. So here, so we want to find the inverse of matrix M, and this is matrix M. So we are going to apply this formula. So we have our inverse of M, which is written as this, is given as 1 over the determinant of what? Matrix M, multiplied by the adjoint of what? Matrix M. So first of all, let's find the determinant of M. So we are going to multiply this. That is going to give us 4 times 3 minus 2 times 5. So this is going to give us 12 minus what? 10, and we have 2. So the determinant of matrix M is 2. Then we find the adjoint of M. So what we are going to do is to interchange the position of what? The first entry and then the last entry. So the 3 will come to the position of the 4, and then the 4 will come to the position of the 3. Then we negate the C and then the D. So we interchange the position of 4 and 3, and then we negate 5 and then 2. That's going to give us what? The adjoint of matrix M. Now once you have this, we are just going to substitute this into the formula. So we have 1 all over the determinant multiplied by what? The adjoint of M. So this is the inverse of this matrix. You can leave it in this way form, or better still, you can continue to expand the bracket. So this is going to give us 3 over 2. Half times minus 5 will give us minus 5 over 2. Half times minus 2 give us minus 1. And then half times 4 will give us what? 2. So this is the inverse of matrix M, as easy as that. Let's look at another example. So we have our next example. Given that this is matrix X, we want to find the inverse of matrix X. So we have inverse of matrix X is given as 1 over the determinant of matrix X multiplied by what? The adjoint of what? Matrix X. So first of all, we have to find our determinant of what? Matrix X. So we have this will multiply that. So we have 2 times 18 will give us 2 times 18 minus what? 9 times 1. This will give us 36. And this will give us what? 9. And at the end, we are getting 27. Now that we've been able to find the determinant, let's look at the adjoint of X. So we have adjoint of matrix X. So with that, as I said, we are going to interchange the position of the 2 and then the 18. The 18 will come to the top. So we have 18, and the 2 will come to the position of the 18. And then once you have this, you negate the 1 and then the 9. As easy as that. Now that we have this, we are just going to substitute this into the inverse formula. So we have our X, inverse of X will be equal to 1 all over the determinant multiplied by what? The adjoint. 18 minus 1 minus 9, 2. Now once you have this, you can leave it in this way form, or better still, you can simplify. So we have our inverse of matrix X. Let's simplify. This is going to give us what? 18 over 27 will give us 2 over 3, right? So we have 2 over 3, and this is going to give us minus 1 over 27. This also give us minus 1 over 3, and this will give us 2 over 27. As easy as that. Let's look at our next example. So we want to find the inverse of matrix A, and we know that the inverse of a matrix is given as 1 over what? The determinant of A multiplied by what? The adjoint of matrix A. So first of all, let's find our determinant of matrix A. So we know that this times this, 2 times what? Minus 2, minus 4 times minus 1, 4 times minus 1. So this is going to give us minus 4 plus what? 4. So the determinant of this matrix is equal to 0. And whenever you find the determinant of the matrix and then you are getting 0, then that matrix has no inverse. And these type of matrices are called singular matrices. So when we talk about singular matrices, we are referring to matrices with no inverse, and then the determinant of such matrices are equal to 0. So you can say that matrix A has no inverse. This brings us to the end of today's lesson. See you tomorrow. Bye bye.